Don't try this at home, kiddies. Hi, in this episode we're going to take a look at the RND Lab 3-channel variable power supply. Now, RND Lab is in fact Distrelec's own brand, so I have to admit the one thing that attracted me to this particular supply was the price. It's about €200, give or take, for a 3-channel variable power supply that's also digitally programmable. And that's a pretty good price. So I mean, the advantage of a 3-channel power supply is if you're doing the type of work that I like to do with microcontrollers and CPLDs and FPGAs, for example, you typically want, well, 1.8 volts, 3.3 volts and 5 volts for your device under test. And again, for other types of electronics, you may want 5 volts, 9 volts and 12 volts. So the ability to get all of that from a single lab power supply is kind of attractive. So the nice thing about this is that you have 2 completely variable channels. So you have 2 channels that can supply between 0 and 30 volts, 0 to 5 amps, constant voltage or constant current. And then you have a fixed channel, which is 5 volts at 3 amps. So you can get pretty much everything you need from the single supply. The other thing is that you have 2 options of the way you control it. You can either use the actual control panel on the device and the display to set the different power outputs or amperage outputs that you want, or it also has a USB and a serial input on the back, so you can connect it to your PC and control it remotely. So if you want to do automated testing, for example, or you want to have several presets that you just recall from the computer, you can use this device too and completely remote control it. So we're going to do 2 things in this episode. Firstly, I'm going to do the usual thing that I do, power it up, take a look at the controls, take a look at the display and see if it's any good. But because it's such a sort of, I don't know, I hesitate to use the expression cheap, but €200 is pretty much a bargain for this type of thing. One thing that I'm really curious about is the build quality of it. I want to know, for a lab power supply, is it well built? Are the cables inside good? Are the boards loose? Is the soldering good? That sort of thing. So what we're actually going to do is that, as a second stage, we're going to pull this thing apart and have a quick look inside and have a look at the build quality of it and see, well, whether it really is the value for money that it seems. The first thing you notice about this unit is the pressed steel case. I mean, it's a good, solid construction. The other nice thing about this is that I've seen some cheaper power supplies that actually have ventilation holes in the top of the supply, and that's a really bad idea on a power supply. I mean, when you have an electronics desk, you're cutting wires and all those types of things. You have small metal particles flying around all over the place. You don't want them falling into your power supply. This unit is side vented, which is a much better idea, so they've obviously got that right. The other thing is that you immediately notice is this nice big display panel on it. So I mean, if we power up the unit, you can see it's an LED panel, which is nice. If you've watched any of my other videos, you'll see that I have a bit of a passion for big, clear displays. I want to be able to easily see what's going on. And this is really nice. It's an LED display, so it's nice and bright, even if you have it in a fairly dimly lit area. And you can see quite clearly the channel 1 and the channel 2 output, the voltage and the amperage settings, that it's in constant voltage mode. And you can also see the memory preset that you currently have set. Now, one of the nice things about this particular power supply, which a lot of cheaper power supplies don't have, is it has an independent control here, so you can actually set the device up and then turn on and off the power to your device under test. The reason why that's important is that on cheaper power supplies, your only real option is to turn it on and off using the power switch here. The problem with that is that when you power on one of these devices, the electronics in the device are unstable as they power up. And that can cause a spike to come out of the actual power output to your device. So if you've got it set up for 3 volts and it's a sensitive device, hitting this power switch could give you multiple more volts than you expect and actually destroy the device under test. So the good thing about this is that you can power it up, let the unit stabilize, you can set the power to how you want it, and then you can turn the power on to your device under test when you require it. And the idea, of course, is that powering it on and off using this control will cause no spiking in the power output. And what we'll actually do, we'll connect this up to an oscilloscope in a moment and have a quick look to see whether that's true and whether you get a nice clean power output from the device when turning it on and off that way. So to begin with, let's power up this power supply in the wrong way. So what I've done is I've set it to immediately output 5 volts as soon as it's turned on. So now we'll just hit the power switch and you can see that there's a little peak there. It's about 5.41 volts. Actually, that's surprisingly good. I mean, the nominal output should be around about 5 volts. So I've seen power supplies do much worse than that, outputting many more volts than they should do when you turn them on. And again, let's turn it off. and there you can see a little bit more of a peak there, 5.7 volts roundabouts. So that's the reason why when you're using these types of power supplies, you should always make sure that you have that on-off switch on the panel to be able to control the device under test. So what we'll do now is we'll just power it up and shut the power off, and just let the oscilloscope stabilize again so we can see the measurement. So now the device, the power supply itself is powered up, but the output to the device under test is off, and you can see that's outputting no voltage at all. And then what we can do is we can turn that on, and you can see that the peak that you get there is much smaller, and again turning it off, nice even drop. So this is the reason why you want a power supply that has this type of control, because I mean when you're turning on and off your device under test, you really don't want big peaks coming through that can damage the thing that you're testing. So this power supply actually performs very, very well. I mean, here with the right way of doing it, pressing this button to get it on and off, the peaking is absolutely minimal. And even when actually turning it on and off from the mains, it was surprisingly stable as it powered up. So let's pull it apart and have a quick look inside. Don't try this at home, kiddies. So there's a couple of things that you can immediately see when you pull this device apart. One is that the steel frame itself actually continues inside the device. I mean, this is nice and solid. There's no way that that's actually going to bend or flex when the device is in use. The other thing is that the circuit boards are very well attached to this device. They're not moving around. But you can also see the way the airflow in this is supposed to work as well. You actually have a forced airflow with a fan. So the air is being drawn into the side of the unit, and then these are all the bridge rectifiers that are going to be controlling the power output, and that's going to be, the air is going to be pulled across the transformer through the fan and then vented out of the back of the unit. So that's a good design. I mean, it's a good forced airflow design where there's no top ventilation required, everything's coming in from the side here. There's a nice fan in the back that looks like an 80mm fan on a big aluminium heatsink. So that's going to be very effective at drawing the heat through the system. And that's important, especially when you've got a ginormous transformer like this in the middle supplying all of that current. The other really important thing that you can see here is the smaller signals, if you like, the lower power side of it, of the device, or the low side, is separated completely from the high side of the device. In a lot of the cheaper power supplies, what you often see is they bundle the connectors together, so you actually have these mains cables handling the 240 volts zip tied to the low power and the signal connections, and that's really bad. So in this one it's really nice to see that not only is it neat and tidy, also the two sides of the power supply are completely separate, and you can see here that everything is actually on plugs as well, so that they haven't actually soldered the wires directly into the PCBs. And that's a nice touch. I mean, it's not strictly necessary, but it's good that they've done it. And you can also see that there's glue around every single one of these, and the glue around these large capacitors here as well. So as the device is being moved around, when it's being transported all the way from China or wherever they make these, it's not going to be vibrating, and things aren't going to be breaking off and falling loose because of that. So if we just turn the device round quickly to see the other side of it, you can see a little bit more about the construction here. So the actual signal, the control signals are coming in this ribbon cable here, so there's no control signals coming through the bundled with these different power connections. Everything has nice little aluminium heat sinks on it. It's actually surprisingly well made. Quite often with these types of devices, the manufacturer can be, it can be a little bit low quality, to say the least, but actually this is surprisingly good. And up here you can see the RS232 and the serial board is separate, and then that's connected then into the main board, which then transfers it over to the control board at the front here. So overall, I mean, it's quite an impressive build. It really has been well thought out. There's plenty of air in there to keep the air flowing around correctly. Everything seems to be bolted down correctly. There's spring washers on all the places where there should be spring washers. The boards are all held in place with multi-points. There's like 1, 2, 3, 4, 5, 6 screws holding the main power supply board in, and everything is nicely made. I mean, these power cables are nice and thick. They're obviously designed to handle the type of power that's going to be flowing through this type of device. So Overall, that's quite surprisingly good, actually. I mean, you would expect for, you know, €200 that this unit costs a bit of compromise in there, but I don't see anything myself. It looks well made, it's properly bolted together, the quality of the components in there and the build quality of the PCBs looks really, really good. So there you have it. That's the RND Labs 320-KA3305P 3-channel digital programmable power supply from Distrelec. I have to say, I'm really impressed with this device. I mean, surprisingly so. I like the display, I like the way that the panel's laid out, the nice big clear displays, but also now having taken the top off and had a look inside, I mean, I like the steel frame, the fact that everything is nicely and sturdily mounted inside there, the good PVC cabling, the separation of the high and the low side of the power supply is really good. The fact that you can control it from your PC over both serial and USB, really nice feature. So I mean, for €200 thereabouts, it's really good value for money.